Good evening, everybody. My name is Eric Whiting, and I will be demonstrating for you the fifth and final feature of DataDrop. So DataDrop, if you haven't been following along, is an application that will take data from one format and export it into another format, basically. Um, so for example, you might have a JSON file that has an array of 6 or 7 different identical objects, and you want to put that into an Excel file or turn it into database inserts. That's what this project accomplishes. So the final feature of DataDrop is creating a library that can be used in other programs, other projects, maybe even exported into a NuGet package or something like that. And that's what we have accomplished. So over here, this is a demonstration of how a programmer or a developer or whatever might use this project in their own project. Okay, so the first block of code I have here, and I don't know if you can see it. I don't know how to record in any better quality, but this is just me setting up some stuff that I'm getting ready to use. This is the initial directory where all my stuff is. This is the name of the JSON file that I'm going to use for the demonstration. This is the JSON file that's tailored for the database schema that I'm going to insert into. And here's a test Excel file, and here's an API source that I came up with last semester for midterm, so that I can show that part as well. And let me just go ahead and show you what those data formats look like. So the test JSON file has 2 objects with their people with a name, job, and age. And that's going to get consumed, and I believe this one's going to get exported into what did I push that into? That one's going to go into am I blind? Okay, so this one's going into Excel, and then the Excel file we have, this one I think is going into maybe XML or something, and then the test db.json file. The reason that the example for the database is different is just because the objects need to be, the object attribute names need to be the same as the column names. So this is the database that I have ready already. Fname, lname, and age, and so those objects have to be named that way for it to work for a database. So not trying to pull anything sneaky on you, just that's why there's a separate JSON file for that. Oh, okay, so now that that's out of the way, so here's the basic usage. Okay, so a programmer, he or she knows that they're going to be consuming a file, either Excel or a JSON file, and they know that in those files there could be any number of column names for Excel or attribute names for JSON. They know that they want the name, the job, and the age out of those options. So they're going to want those attributes, and those will end up being column names, and they want the values as well. So if when it goes into Excel, it's going to be the column names, and then under those columns it's going to be the values for the respective columns. And this is how they would do it. The data format classes take in a list of strings to know which attributes to keep. I had originally intended to add a string array constructor, but never got around to it. But it would take about 5 minutes to implement. Aside from that, it's going to take in the full path to the file. Um, the attributes are the attributes that are going to be kept, and then the source data type is an enumeration that has JSON and Excel, and this parameter is what's going to tell the data format class how to format the data that it's going to receive, because it has to do something different for JSON, has to do something different for Excel, and all that stuff. So now you may not always get the attributes that you think are coming in. Excuse me, especially if you're working with something case sensitive. Maybe you say age, but really it wanted age with a big A. So we had to implement the option class. Excuse me, I'm sorry. And this was actually Ramya, and we implemented that into the data object class. So the data object class is the kind of the bread and butter of the data format classes, which is the main abstract class for this whole project. The data object class is kind of the purest form of data, I guess you could say, because the data objects they have these data pairs, right? And it's just a dictionary, string, dictionary, because no matter what data you're taking in, you're always going to have a value that has a key. So if you're consuming an Excel document, every value in the rows is a dictionary value essentially of whatever that column name happens to be. Same with JSON. JSON, it's a little more obvious because it's actually kind of formatted like a dictionary. So this is the key. This is the value. Same with XML or just anything really. So this is the heart and soul of the data format class, is a list of dictionaries. And so sometimes you might ask it for the wrong thing, and so what we have here is we've implemented the option class, and let me show you actually how we built it. We didn't use Liumba. We kind of did some of our own research. Excuse me. Okay, so we implemented option as an abstract class that takes in a type, right? And and so the option class has two constructors, and it can either construct itself into a sum or a none, because it's got these two sealed classes, or I think derived classes is the right word. I'm actually not sure. But basically, anytime you use an option, you'll either get a none or a sum, right? And it's kind of up to you, I believe, when you use option instead of either, how to handle or how to decide when something is none and when something is sum. So in our case, oh goodness, what is this? All right, there we go. In our case, what we did is we iterated through the list that would be passed to this object after it's been constructed, and we loop through it, and for each dictionary, because it's a list of dictionaries, which gets a little bit confusing sometimes, but I digress. So for each item in the list of dictionaries, it goes to this try get pairs method, and basically it checks if the keys are good and it checks if the values are good. And I like how this kind of ended up, because this kind of just ends up reading like English, right? And so if the keys are good and the values are good, excuse me, this gets pushed into into the actual data pair list. And the good thing about that is that should catch any any exceptions that you might get from a dictionary, like having a dictionary that has two identical keys, or having nothing there. You don't want to deal with that, especially if and the reason we check for both is because when you're dealing with a dictionary and we're dealing with like the dimensionality of all the data that we're working with, we if you skip a key from a dictionary but the value is there, and then you keep going, you run the risk of having your data off by one. So the dictionary item that had a null key might end up, the next dictionary item, that thing's key might end up being the wrong thing's key. You know what I'm saying? So excuse me. So it's important to kind of handle your data, and to make sure that both the key and the value are good before you actually add it to your attribute to be used and in whatever way that you've decided. But anyway, so that's enough of that. Okay, this is the demonstration for feature 5. Like I already explained here, this is how a programmer would implement everything in kind of a basic usage. This is an example of using an API. So this is the endpoint that we're hitting, and this is how the data looks when we hit it. And so what's going to happen there is we're going to export this data into XML. So this is kind of, I would actually think that this might be the typical use, especially if you're gathering a bunch of historical data, like say you're using a weather app or a weather API, and you're gathering the data for the weather from yesterday, 2 days ago, 3 days ago, all the way to like a year ago, and you want all of those put into Excel. You can just make a loop and loop through the dates, hit that API in right here, and just append the date to the API parameter, and just you'd end up with 365 XML documents. And then finally, here's the database demo. Excuse me, I kind of don't see this being used a lot. I thought this was cool the first time I did it, but most of the time, if you just use entity framework, you could just just use the object.save if you've got all your objects and tables formatted or mapped together. So this might actually not ever get used, but I think it's still pretty cool. And the reason it's so much longer than the other kind of blocks here is because since it is a database function, we've got to deal with all the connectivity issues. So this is particularly not interesting. This is just that's going to end up being my computer's name for the server, the database name, the user, and the password. This is not my real password. Don't try to hack my Facebook. And then the database data format constructor takes all of those. There has to be a better way to do this, but I couldn't think of one. But anyway, so it's going to take in that test.db JSON that we looked at and insert it into this database right here, or this table right here. So without further ado, I know it seems like I talked a lot, but this program, I'm going to hit run, and it's gonna run for like a second, and then all right. So it's running. Oh no! What happened? Oh, you know what? I deleted that file. Oh no, wait, no, I didn't. It's because I have it open because I'm an idiot. Okay, I'm sorry. Let me just close everything, and let me try that again. So that we might have ended up with things running twice, but okay. Okay, so it ran. And let me bring him over here. Okay, so let's see what we got. Here are, okay, there's only one of each. So here is the results, most of them. Okay, so let's look at this Excel first. So remember, we built this Excel from that JSON file. So this JSON file right here, name Eric, job programmer, age 30, and then Bob, the DBA, who's 33 years old. It exported that into an equivalent format for Excel. Likewise, we took in the test Excel file, which was these guys. None of these are real people, just FYI. And what did we push that into? I can't remember. I think XML. I'm sorry if my voice is waning. I'm a little sick. No, we pushed that one into JSON. So let's go look at what that looked like. Yep. There's all that. There's all these people that aren't real. And then this database JSON object that we pushed to the database. Let's see if it made it. Fun fact, if you hit Control-R, you can totally refresh this thing. And there is our buddy Bob and our buddy Jon Snow. I don't know why it's in that order. That's weird. And then, is that it? No, and then the XML test. So let me open that with Notepad. I know this is hard to see. I have a XML format already. Yep, and there we go. So this was this was the data that came out of that API. And what a misleading scroll bar. Oops. Okay, so those are all those data points from here. Alright, so that is feature 5. That is of DataDrop, allowing a developer to consume this project into their own project. Obviously, it wouldn't be as straightforward as this. There'd probably be a lot less hard-coded values. But yeah, that is feature number 5. Thank you for watching, and let me know if you have any questions.